So you have learned a little bit about functions in JavaScript. In this section, we're going to examine functions in more detail. So I'm going to start by defining a function called walk. And here we do a console.log of walk. What we have here is what we refer to as a function declaration. But in JavaScript, there is another way to define a function, and that is using a function expression. So we start by declaring a variable or a constant, give it a name like run, and then we set that to a function. So just like we can set a variable to a number or a string or an object, we can also set it to a function. And you know that in JavaScript, functions are objects. So setting the run variable to a function is similar to setting it to an object, okay? And at the end here, we need to add a semicolon, because whenever we declare a variable or a constant, we terminate this statement with a semicolon. So here's another example. We set x to 1 and terminate it with a semicolon. In contrast, we don't put the semicolon when we define a function using the function declaration syntax. It doesn't really matter. So if we run this code, we're not going to get any errors. But by convention, we don't do this. So that's one difference between function declarations and function expressions. Now, let's do a console.log of run here. So basically here we have defined a function, and this function does not have a name. Its syntax is very similar to what we have in a function declaration, except that here we don't have a name. We can give it a name, and then we would refer to this as a named function expression, or we can exclude the name. And with this, we'll have an anonymous function expression. So we have defined an anonymous function that doesn't have a name and set run to reference that function. So now we can call that anonymous function using this reference, just like how we call a function in JavaScript. So save the changes and we get the run message on the console. Now we can declare another variable, call it move, and set it to run. So now both move and run are referencing the same anonymous function, which is one object in memory. So we can call that anonymous function using this other reference. So if we call move, we get the same result. So to recap, in JavaScript, there are two ways to define a function. We can use the function declaration syntax or function expression, which basically involves declaring a variable or a constant and then setting it to a function. In the next lecture, we'll look at the key difference between a function declaration and a function expression. In this lecture, you learn about function declaration and expression. Now, the key difference between these two functions is that we can call this function, the one that is defined using the function declaration syntax, before it is defined. So here we can call walk, save the changes, and we get this message on the console. But we cannot do this with a function that is defined using the function expression syntax. So here, if I call run before it is initialized, I get this error, uncaught reference error. Run is not defined. This is exactly like using a variable or a constant before it is defined. For example, here I'm going to define x and set it to 1, but I want to log it on the console before its declaration. Look, we get the same error. Reference error, x is not defined. So we can call a function that is defined using the function declaration syntax before its definition. But why is that? The reason for this is because when our JavaScript engine executes this code, it moves all the function declarations to the top. So our code will look like this at runtime. This is what we call hoisting. So if you are in a job interview and somebody asks you, what is hoisting in JavaScript? Hoisting is the process of moving function declarations to the top of the file. And this is done automatically by the JavaScript engine that is executing this code. So that's the reason we can call functions that are defined using the function declaration syntax before their definition. Here in the course, you learn that JavaScript is a dynamic language. So we can declare a variable, set it to a number, and then change its type and set it to a string. And that's perfectly fine from the perspective of a JavaScript engine. This is one of the characteristics of a dynamic language. But we have the same concept in the arguments of a function. So I'm going to define a function here, call it sum, that has two parameters, a and b. And here we simply return the sum of a and b. Now let's do a console.log and call the sum function, pass 1 and 2, save the changes, so we get 3. But in JavaScript, it doesn't matter that this function has two parameters. We can pass only one argument. So in this case, we get not a number, because here a is 1 and b by default is undefined. So when we have un plus undefined, the result is not a number. This is not a valid arithmetic operation. The same happens if we don't pass any arguments. So we don't get an error, we get not a number as a result. By the same token, we can pass additional arguments. So in this case, we can pass, let's say, 5 arguments. And that's perfectly valid JavaScript code. So when we save this, we still get 3 because only the first 2 arguments are used. But what if you want to have a varying number of parameters in a function? What if you want to have the flexibility to pass as many arguments as we want and get their sum? Well, every function in JavaScript has a special object called arguments. Let's log this on the console, console.log. So this is the arguments object. You can see that it kind of looks like an array, but it's not an array, it's an object. But the keys we have in this object are the indexes of the arguments passed to this function. So the first argument is 1, the second argument is 2, and so on. Here we have a length property that returns the number of arguments that are passed. We have this other property, callee, which returns the currently executing function. So you can see here we have a reference to our sum function. So this is the arguments object. Now, if you want to have a function with a varying number of parameters to work with all the arguments that are passed to this function. So let's say we want to change this function to return the sum of all its arguments. Here's a very simple algorithm. So we declare a variable called total, set it to 0. Then we can use the for of loop. So let value of arguments. We can use this loop to iterate over this arguments object. Now, earlier I told you that we can use the for of loop on arrays, but technically this loop can be used on any object that has an iterator. So the plain objects that we create with the object literal syntax, they don't have an iterator, but this particular object, you can see here we have symbol.iterator. That means this object has an iterator, so we can use the for of loop to iterate this object. Now, for every argument, we're gonna get that and add it to our total variable. And finally, we will return total. Now, save the changes. We get 15. We can add another argument and we get 25. Now, here's the interesting thing. We can completely remove these parameters here because technically here we are working with the arguments object to access the arguments that are passed here. We are not referencing A or B anywhere in the body of this function. So we can simplify this code and remove these parameters. In the next lecture, we're going to look at a better way to implement this function. Modern JavaScript, if you want to have a function with varying number of parameters, you can use the REST operator. Let me show you how that works. So here we modify the declaration of this function, add a parameter, let's call it args, and then prefix it with 3 dots. This is what we call the REST operator. Now don't confuse this with the spread operator because spread operator looks exactly the same. Earlier we used the spread operator with arrays. So with the spread operator, we can spread an array, which basically means taking its individual elements. But when we use this, along with the parameter of a function, we refer to this as the rest operator. And you will know why this is called rest in a second. So let's see how the rest operator works. I'm going to delete all this code and simply do a console.log of args. So here we're calling this function with 6 arguments, save the changes. Now here on the console, you can see args is an array of 6 elements. This is a real array. Note that if I remove these 3 dots, that basically means this function has a single parameter called args. So when I save the changes, instead of this array, you're going to see 1 because the first argument that we're passing to this function is 1. Save the changes, we get 1. So here's the lesson. When we apply the rest operator to a parameter of a function, we can pass varying number of arguments, and the rest operator will take all of them and put them in an array. Now, if you want to get the sum of all the numbers in an array, we can use the reduce method. You'll learn about that in the section about arrays. So args is an array. We can call the reduce method and pass an arrow function here. A and B goes to A plus B. You've done this before, right? So we simply return the result. Save the changes, and we get 25. So you see, in modern JavaScript, we can achieve the same functionality with less code. Instead of defining a total variable, setting it to 0, and then looping over the arguments object, we can have one line of code that gives us the same thing. And this is more elegant and more professional. Now let's take this example to the next level. Imagine we're going to use this function to calculate the total cost of items in a shopping cart. Here, let's say we want to have a discount factor. So I'm going to add a parameter here, discount, and then rename args to, let's say, prices. So we're passing the price of all the items in a shopping cart. Now let's change line 8 where we call the sum function. Let's say we're going to pass 0.1 or 10% for the discount, and we have 2 products in our shopping cart with prices $20 and $30. So here, instead of returning the sum of all the items in the prices array, we're going to store the sum here in total. We don't need this anymore. And then we want to return total times 1 minus discount. So if discount is 0.1, we subtract it from 1, we get 0.9. Then we multiply it by the total, and this will return the final price after the discount is applied. Save the changes, so we get 45. Now let me show you something. I'm going to add one parameter after prices. Let's call that sum value. Now on line 7, where we call this function, let's pass a new value like 1. Save the changes, we get this error. Rest parameter must be last formal parameter. So we cannot have a parameter after using the rest operator. So here, prices is a rest parameter, so it should be the last parameter in a function. Let's remove this. And this is the reason we call this rest, because we can have 0 or more parameters before this. In this case, we have discount. So we have discount and the rest of the parameters or the rest of the arguments that are passed to this function. That's the reason this operator is called the rest operator. There are times that we want to supply default values to the parameters of a function. For example, let's imagine we want to write a function for calculating the total interest. So here we have 3 parameters: principal, interest rate, and years. And here's the formula to calculate the total interest. Principal times rate divided by 100 times years. Now, let's call this function. Let's imagine the principal is $10,000, rate is 3.5%, and we want to pay this back over 5 years. So let's log this on the console. So the total interest we have to pay is just over $1,700. Now, what if we want to have default values for the interest rate and the number of years? Well, earlier in the section about operators, I showed you a technique like this. So rate equals rate or 3.5. So if rate has a value, if it's truthy, we're going to use that. Otherwise, we're going to use 3.5. So we can use the logical OR operator to give a variable a default value. Similarly, we can set years to years or 5. With this, if we exclude these arguments, those default values will be used. So I'm going to delete these, save the changes, and you can see we still get the same result. But starting from ES6, we have a cleaner way to achieve the same thing. So instead of having these logical expressions, we can set the default values right here. So we set rate to 3.5 and years to 5. And now we can delete these two lines, save the changes, we'll still get the same result. So you can see setting the default value for function parameters is really easy. There is just one caveat here. Once you give a parameter a default value, you should also give all the other parameters after that a default value. For example, let's see what happens if we set the default value for rate, but not for the years. When we save the changes, we get not a number. Because we passed 10,000, so principal is 10,000, rate is by default 3.5, but years doesn't have a value, so it's undefined. That's why the result of this expression is not a number. Now, what if we pass 5 for the years? Well, this is confusing for the JavaScript engine because it doesn't know if 5 should be used for rate or for the years. So if I save the changes, we still get the same result, not a number, because in this case, 5 is used for the rate, but years is still undefined. Now, there is a trick around this, so we can pass undefined for the second parameter, and with this, rate will be set to 3.5 and years will be set to 5. Let's save the changes. Now we get the same result as before. But code like this is really ugly. Somebody looking at this code, they wonder, what is this undefined? They have to look at the function to figure out what parameter is associated with undefined. So as a best practice, whenever you want to give a function parameter a default value, make sure that that parameter is the last parameter in the list, or give all the parameters after that a default value. We're going to look at a special kind of methods in objects called getters and setters. So let's imagine we have a person object with two properties. First name, we set this to Mosh, and last name, we set this to Hamedani. Now, somewhere in our application, we want to display a person's full name. So we have to do something like this. Console.log, we can either get the person.first name concatenated with space and then last name, or a better way, as I told you before, is to use a template literal. So we use the backtick, and then we add a couple of arguments here. So here's the first one. The argument is person.first name. Now we have a space, and here's the second argument, person.last name. However, the problem with this approach is that maybe there are multiple places in our application where we want to display someone's full name. With the current implementation, we'll have to repeat this template literal in multiple places. A better approach is to define a method in this object, call it full name, and move this expression right there. And then whenever we want to display a person's full name, we simply call that method. So we can add another key value pair, full name, but we set the value to a function. Or as I told you before, in ES6, we have a shorter syntax to add a method to an object. So instead of adding it as a key value pair, we can add it as a function without the function keyword. So if we want to define a function outside of an object, what do? We add function, the name of the function, parentheses, and curly braces. However, when we need to add this inside of an object, we just drop the function keyword. So you can see this new syntax is shorter and cleaner than the older syntax. Okay, so here's our full name method. We simply return this expression here. So I'm going to cut this and move it here. Now with this new implementation, every time we need to display someone's full name, we simply call person.fullname. Save the changes, we get Mosh Hamedani. Beautiful. However, there are a couple of problems with this approach. The first problem is that this is read-only. In other words, we cannot set a person's full name from the outside. It would be nice if we could do this, and then the first name and last name properties would be automatically set based on what we pass here. The other issue is that I don't like to call this like a method. It would be nicer if we could treat this as a property, so we could drop the parentheses like this. So how do we do this? Well, that's where getters and setters come in the picture. We use getters to access properties in an object and setters to change or mutate them. So in this object, we should add a getter, and with that getter, we can read this person's full name like a property, and with the setter, we can set it from the outside. So here is how it works. We prefix this method with the get keyword, and now this method is a getter. So we can access the full name like a property on line 15. Let me temporarily comment out this line. Save the changes. You can see our program is still working. Beautiful. So this is our getter. Now, to be able to set this from the outside, we need to add a setter. A setter is very similar. So we add the set keyword, the name of the property or method, and then code block. However, this method needs a parameter. We can call it value or anything. And the value of this parameter would be what we have on the right side of the assignment operator. So here, let's assume that value is a valid string. We need to split that string by a space, take the parts, and set the first name and last name properties. So value, we call the split method of strings. We want to split it by a space. This will return an array. We can call that parts. Now we can set the first name to parts of 0 and last name to parts of 1. And finally, instead of logging the person's full name, let's just log the person object. So initially, we set the first name and last name to Mosh Hamedani. Now with this new property, which is actually a setter, we're changing the name to John Smith. Save the changes. Here's our person object. You can see first name and last name properties are updated. Also, note that full name, its value is ... Sometimes when you're logging objects in the console, you may see properties with this kind of value. As you can see from the tooltip, this is a getter. In order to read the value, you need to click here. And now this method is executed and the result is returned in the console. So this is the benefit of getters and setters. In the next lecture, we're going to look at error handling. In the last lecture, we assumed that the value that we receive here is a valid string. But what would happen if we pass a Boolean here? That doesn't make sense, right? So let's run this code. We get this error. Uncaught type error. Value.split is not a function because split is a method that belongs to strings. Booleans don't have a split method, right? What would happen if we pass null or undefined? Save the changes. We get a different error. Cannot read property split of null. Again, for the same reason, we cannot call the split method on a null. It's only available on a string. So here we need to add error handling. Typically, in situations like this, we should do error handling at the beginning of a function or a method. This is what we call defensive programming. So we want to make sure that the values that are coming in are valid, they're in the right shape, so we can execute our logic. So the first line of this method should be something like this. We want to make sure that this value is a string. So we can use the type of operator. If type of value is not string, then one simple approach is to return. And with this, we'll no longer see this error message here. Save the changes so we can see the person object with the original first name and last name. So what we passed here, null, did not take effect. But sometimes we want to report an error in our application. That's where we need to throw an exception. Throwing an exception is a technical jargon that you might hear in a lot of programming languages. So let's see how that works in JavaScript. So instead of returning from this method, we use the throw keyword, and then create a new error object. So new error, that looks familiar, right? So error is a constructor function because here we have the Pascal case, and we're calling this function using the new operator to create a new error object, right? Now, as an argument, we can pass an error message. So value is not a string. So this is how we throw an exception. Now, some people confuse errors with exceptions, but there is a slight difference between the two. Here we can create an error object. Let's call that E, new error. This is just a plain JavaScript object. There's nothing special about this. But the moment we throw this error, we refer to that as an exception. So this is an exceptional situation that should not have happened, okay? Now, in this method, we have some basic error handling. So this method is throwing an exception. Now somewhere else, we need to catch that exception. We need to catch that, and quite often when we catch an exception, we display an error to the user. So this is how we accomplish this. Line 15 is where we receive this exception. So we need to wrap this line in a try block. So try, remove this line here. So try block can have one or more statements. One of these statements at least can throw an exception. Now, we add the catch block after. In parentheses, we give an identifier. This is the error object that we are throwing here. So in the catch block, we can get that error object and do something with it. So here, we can display it on the console. But as you know, this is only visible to developers, so an end user will not see this error. So temporarily, we can use the alert function. This is not something that I recommend you to do because that's a very old and poor way of reporting errors to users. The proper way is to display a label, perhaps a red label on the user interface. But that's a topic for a future video. So for now, let's just use the built-in alert function. Now, save the changes. And here's our alert. Value is not a string. Now let's take this to the next level. Instead of passing null, I'm going to pass an empty string. Save the changes. We don't get any errors, but first name is an empty string and last name is undefined. Again, that's not desirable. So ideally, we want to make sure that our user is typing a first name and last name. So when splitting that string, we can check the length of this array. So if part.length is not 2, that means something is missing. So here we can throw another exception, throw new error with a different message. Enter a first and last name. Okay, now save the changes. And here's our new exception, enter a first and last name. So basically, when we throw an exception, the lines after the throw statement are not executed. We'll jump out of this method and the control will move to the catch block. Here we catch the exception and do something with it. So this is the basic of error handling in JavaScript. In this lecture, we're going to talk about a very important concept called scope. So I'm going to define a constant called message and set it to high. Now let's log this on the console. So obviously we get high on the console. But what would happen if I add this message in a code block? Let's save the changes and see what happens. We get this error, uncaught reference error. Message is not defined. This is all about scoping. So a scope of a variable or a constant determines where that variable or constant is accessible. And when we declare variables and constants with let or const, their scope is limited to the block in which they are defined. So message is accessible in this block, but it's not accessible outside of this block. Now you might be wondering, why do we need this code block here? Well, this code block can be part of a function. So here we can have a function called start. And now we have a constant in this function. So because the scope of this constant is limited to the block in which it's defined, we cannot access this constant outside of the start function. The same is true when we declare a variable or a constant in an if block. So let's add an if block here. Some condition, we don't care. Let's declare another constant and set it to by. Now, this constant is only accessible in this block. If I go out of this block and try to log it on the console, we're going to get an error. So I'm going to remove the last line. Let's just call the start function. Save the changes. We get the same error, reference error. Another is not defined. We have the same concept in our loops. So let's define a for loop. Let I equal to 0. We're going to run it 5 times. Now, I is a variable that is only accessible in this block. So here we can log I. Let's save the changes. We get numbers 0 to 4. But if we go outside of this for block and log I, we're going to get the same error. Reference error. I is not defined. Now, let me simplify this code. So we're going to have a function with a constant called message. We can have another function. Let's call that stop. And in this function, we can have a constant called message with a different value. That's perfectly valid JavaScript code because the scope of this constant is limited to the block in which it's defined. So we can have 2 variables or constants with the same name but in different functions. That's perfectly valid. Now, what if we define a variable or a constant outside of a function? So here I'm going to define a constant, color, and set it to red. Now here we don't have any code blocks. So what do you think is the scope of this constant? This constant has global scope. Global means this constant is accessible everywhere, globally. So we can go to the start function and log color, save the changes. You can see we have access to this constant color, right? So this constant is accessible in all the functions we have in our program. Now, what if we have a constant with the exact same name in our function? So let's take a look. I'm going to define this color constant, but set it to blue. What do you think we're going to see when I save the changes? Let's take a look. We get blue. So local variables or local constants in a function take precedence over global variables or constants. Now, in general, you should avoid defining global variables or constants. That is considered bad practice. Let me give you a metaphor. Imagine this is a toothbrush and each function is a person. You don't want to have a toothbrush that is shared between multiple people. Each person should have their own toothbrush. So you should avoid defining global variables or constants because they're accessible everywhere globally, and each function can accidentally change their value, and this will lead to all kinds of bugs and issues in our programs. I've been declaring variables using the let keyword. But at the beginning of the course, I briefly mentioned that there is another way to declare variables using the var keyword. And you may see this in a lot of JavaScript code online. In this lecture, we're going to look at the var keyword. You're going to learn about the problems with the var and why you should avoid it. So let's start by defining a function, start. Here we're going to have a loop. Let I equal to 0. We're going to run this loop 5 times. And in each iteration, we're going to display I on the console. Now let's call the start function, save the changes. So we get numbers 0 to 4. Now in the last lecture, you learned that I is only accessible inside this block. So if we try to log I outside of this block, we're going to get an error. I is not defined. Now I just want to clarify something. We still have the same concept if I remove this curly braces, because here we have a single statement. So the scope of I is still this block here. Okay, so save the changes. We still get the same error. However, let's see what happens when we replace let with var. Save the changes. What happened to our error? So it turns out that I is accessible outside of this for block. So in the last iteration, I becomes 5. Because 5 is not less than 5, so the loop terminates. And here on line 6, we're displaying the current value of I. So this is the issue with the var keyword. When you declare a variable with var, its scope is not limited to the block in which it's defined. It's limited to the function in which it's defined. And this is not how most or all programming languages out there work. It's one of those weird things in JavaScript that we have had for a long time. So before ES6, var was the only way to declare variables and constants. Starting from ES6, also called ES 2015, now we have two new keywords, let and const, to define variables and constants. These two keywords create block scoped variables, but var creates function scoped variables. Let's take a look at another example. So in this for loop, let's add a code block here. Now I'm going to add an if statement. Now in the if block, I'm going to declare a variable using var, color, set it to red. Now technically, in almost all programming languages out there, this variable should only be accessible in this block. But because we have used var, color is accessible anywhere in this function. So at the end of this function, we can log color, save the changes. Look, we get red here. But if we replace var with let, we get an error because color is not accessible here. And that's how most languages work. So this is the first problem with the var keyword. The second issue is with global variables. So let's delete all the code here. I'm going to declare two variables, one with var, color, we set it to red, and one with let. Let's say age and set it to 30. Save the changes. Now, when we use var outside of a function, this creates a global variable and attaches that global variable to the window object in browser. So in browsers, we have this window object, which is a complex object with lots of properties and methods. When you want to build front-end applications, you're going to work with this window object a lot. Now, what matters here is this var keyword attaches this color variable to the window object. So if we type window dot, look, our color variable is here. In contrast, when we use the let keyword to define a global variable, that global variable is not attached to the window object. So if we type window.age, you can see it's undefined. So why is it bad to attach a variable to the window object? Well, because window object is something central, there is only one instance of the window object. And let's say you're using a third-party library. If that third-party library also has a variable with the same name, that variable can overwrite your variable. So you should avoid adding stuff to the window object. Otherwise, you're going to create all sorts of issues in your programs. Now, for a curious developer, I need to mention that when we define a function, let's say hi, this function is technically a global function and is added to the window object. So let me save the changes. If we type window.sayHi, see, our function is here, so we can call it. So technically, this is a global function. It's attached to the window object, and that is bad practice. But how can we prevent this? Well, later in the course where I talk about modules, you will learn how to encapsulate these functions in separate modules so they are not added to the window object. So here's what I want you to take away from this lecture. Avoid using the var keyword because it creates variables that are function scoped, not block scoped. That confuses a lot of developers, but honestly, I think it's because of the poor teaching materials out there, because I personally was confused about the this keyword for a long time. So in this lecture, I'm going to make it super simple for you so you can explain it to your 7-year-old brother. So what is this? This references the object that is executing the current function. Here I'm going to give you a very simple rule of thumb. If that function is part of an object, we call that function a method, right? So if that function is a method in an object, this references that object itself. Otherwise, if that function is a regular function, which means it's not part of an object, this references the global object, which is the window object in browsers and global in Node. Let's take a look at a few examples. So I'm going to start by creating a video object. In this object, we're going to have a title property and a play method. Let's log this here and finally call video.play. Save the changes so we get our video object on the console. So in this example, because play is a method in the video object, this references this object itself. By the same token, we can add a method later in this object and we'll get the same result. For example, we can add a stop method here, set it to a function, and here we can do console.log of this. If we call the stop method, once again, we're going to see the video object on the console. So save the changes, and here is our video object. Because again, stop is a method in the video object. So that's an example of the first rule. Now let's take a look at an example of the second rule, a regular function. So let's delete this and instead add a function called play video. If we log this on the console, we're going to see the global object, which is window in browsers and global in Node. So let's call this function play video and save the changes so we get the window object here. Now, what if this is a constructor function? We call the constructor functions using the new operator. So let's rename play video to video with a capital V. That's the convention for constructor functions. Now here we're going to pass a title property and set this the title to title. Now we can use this constructor function to create a new video object. So we use the new operator, save the changes. Oops, I forgot to pass a title here. That's the title. So what do we get here? Instead of the window object, we get a new object. Now note that this object is not this video object here. It's completely separate. To demonstrate this, I'm going to change this argument to B. So instead of the window object, we get this video object. Because earlier in the course, I told you that when you use the new operator, this new operator creates a new empty object like this and sets this in this constructor function to point to this empty object. So here on line 12, we add the title property to this new object. So let's recap. When dealing with a regular function, this by default references the global object. But if you call a function using the new operator, which is the case for constructor functions, this will reference a new empty object. Now, the last example. I'm going to clean up this code. Let's add another property in this object, tags. We set it to an array of 3 strings. Now let's rename the play method to show tags. So here we can use this to get the current object and then get the tags property. Because this is an array, we can call the for each method. And here we need to pass a callback function. So function. In each iteration, this function will get a tag, and then we can display the tag on the console. So console.log of tag. Finally, let's call video.showTags. Save the changes. So we get A, B, C. Beautiful. But what if we want to display the title of the video next to each tag? Well, we can add this, the title here, save the changes. We got undefined. What's going on here? Well, let's remove the title property and see what this is referencing. Save the changes. It's referencing the window object. But aren't we inside a video object here? Shouldn't this reference the video object? No, because here we are inside this callback function. This function is just a regular function. It's not a method in the video object. The only method we have here is show tags. So because this is a regular function, this references the global object. So it's the global object that is executing this anonymous callback function. But how can we solve this problem and display the title of the video next to each tag? Well, we have a few different solutions for this. In this particular case, the for each method has two parameters. The first parameter is our callback function. The second parameter is this arg. So we can pass an object here, and this will reference that object. For example, here I can pass a new object with the first name set to Mosh. Now, when we save the changes, you can see this is referencing this new object. Now, in this example, we don't really want this object. We want our video object. So we can pass this here. Because at this point, we are in the show tags method. So this references the current object. So here we are not inside of a callback function. We're still in the execution context of the show tags method. So now if we save the changes, next to each tag, we can see our video object with this title property. So we can add the title property here. And with this, we see the title of the video next to each tag. Beautiful. But not all methods in JavaScript give you the ability to pass this argument. So we have a few different solutions for that, and that's the topic for the next lecture. In this lecture, you learned that this references the object that is executing the current function. All right, now let me show you a few different solutions to change the value of this in a function. So let's imagine our for each method doesn't have this second parameter. How can we change the value of this? Well, here is one simple solution. Before we call the for each method, we can define a constant, call it self, and setting it to this. Some people also call this that. It's more of a personal preference. There's no right or wrong. So let's call this self. Now at this point, self is referencing the video object here. So in our callback function, we can use self instead of this, because the value of this changes when a new function is called. So at this point, this references the video object, but when we get to this callback function, this references the global object. So here we can use self, which is the original value of this, save the changes, and we get the title of the video here. Beautiful. Now, this is not the preferred approach, but it's something that you see in a lot of JavaScript applications out there. So I just want you to understand it, but don't use this approach. Now let's take a look at another approach. Earlier in the course, you learned that functions are objects in JavaScript. So let's define a function, call it play video. Here we do a console.log of this. So this function is technically an object. So it has properties and methods that we can access using the dot notation. Here we have three methods: apply, bind, and call. And with these, we can change the value of this for this function. The simplest is the call method. The first parameter of this method is this arg. So here we can pass an object, and this will reference that object. For example, I can pass a new object with the name property set to Mosh. Now, when we save the changes, we're going to see this object on the console. But before we get there, let me temporarily comment out this previous code. So save the changes. You see this new object. In contrast, if we call this function using the standard function call syntax, this references the window object. So this is the benefit of using the call method. We have another method that is similar to call, and that is called apply. So let me duplicate this line, change this to apply, save the changes. Again, we get the same result. So what we pass as the first argument here will be used as the value of this. The difference between call and apply is only about passing arguments. So if this function has multiple parameters, let's say A and B, we can supply multiple arguments here, 1 and 2. But with the apply method, we have to pass them as an array. So 1 and 2. That's the only difference. We have another method that is bind. So play video.bind. Once again, the first argument is this arg. So we can pass this object name Mosh. But this bind method does not call our play video function. it returns a new function and sets this to point to this object permanently. So no matter how we call that function, this will always point to this object that we pass here. So this returns the new function. We can store the result in a constant and now call this function just like a regular function. Save the changes. Once again, we get this new object here. Now, in this particular case, we don't really need this separate constant. We can delete this and immediately call the function that is returned from the bind method. Save the changes, we get the same result. So with call, apply, and bind, we can set this argument for a given function. Now, let's go back to our previous example. So let's delete all this code here. Back in the show tags method. So here we're passing this callback function, and in this function we're going to use this. So we no longer need the self constant. However, as you know, by default here this references the global object, but we want to change this. So here we have a function. We can call the bind method immediately here, and then pass an object to be used as the value of this. What should we pass here? This. Because as I told you before, at this point, we are in the show tags method. So this references our video object. So save the changes. And once again, you can see the title of the video next to each tag. So using the bind method is the second solution to solve this problem. But there is a newer and better solution. Starting from ECMAScript 6, we have arrow functions. The good thing about the arrow functions is that they inherit this value. Let me show you what I mean by that. So let's remove the call to the bind method and change this function to an arrow function. So we remove the function keyword, put a fat arrow between the parameter and the body, and because we have a single parameter, we remove parentheses. Cleaner syntax. Now if you save the changes, we still get the same result without doing anything extra. The reason for this is because arrow functions inherit this from the containing function. So in this function, this references the video object. So when we pass an arrow function here, the same this value is used in this arrow function. In other words, this is not rebound to a new object. So let's quickly recap. In this lecture, you learned about 3 ways to change the value of this. The first solution was using the self approach. So the second solution was using the bind method. So right after defining this function, we call bind and pass this as the argument. But again, this is the old way of doing things. It's a little bit noisy, but you may still see it in a lot of JavaScript applications out there. So going forward, the modern approach to solve this particular problem when dealing with callbacks is to use an arrow function. Now it's time to practice what you have learned in this section. So here's your first exercise. I want you to create a function called sum that takes a varying number of arguments and returns their sum. We can pass 1 argument or 2 or 3 or more. So here we should get 10. So do this first, and then to challenge yourself, modify the sum function to be able to accept an array and still return the same result. Now, as part of this challenge, you need to detect if the argument that is passed is an array. To do that, we use array.isArray method. So let me show you how this works. We can call array.isArray. If we pass an array object, we get true. If we pass anything else, like a regular object, we get false. So pause the video. When you're done, come back, continue watching. All right, let's create this function called sum. Now to have a varying number of parameters, we use the rest operator. So ... items. Now we can pass as many arguments as we want, and this spread operator will convert them all to an array. So we have an array. To get the sum of items in an array, we can use the reduce method. So items.reduce, we pass an arrow function, a and b goes to a plus b. And finally, we return the result. Now let's call this function. So console.log of sum of 1, 2, 3, 4. Save the changes. We get 10. Beautiful. Now let's work on the challenge. So if we pass these arguments in an array, with the current implementation, instead of getting 10, we get the array itself. Let's see why this is happening. So in this function, I'm going to log items, save the changes. So items is an array of arrays. Look, here we have an array, and the first element in this array is this array of numbers. Because I told you that the rest operator converts whatever we pass here into an array. So because we're passing an array of 4 numbers, this rest operator would put this array inside of another array. And that's why we don't get the sum of these arguments. How can we solve this issue? Well, we need to check to see if this items array has a single element and the first element is an array itself. So we can do something like this. If items.length equals 1, and we want to see if the first item is an array. So array.isArray, we pass items of 0. If that's the case, we need to flatten this structure. So instead of having an array of arrays, we want to have just an array of numbers. How do we do that? We use the spread operator. So we reset the items to a new array, and we use the spread operator to spread items of 0, which is another array. That's the array we have here, right? Now, let's save the changes. We get 10, beautiful. So we can pass an array to our function or individual arguments, and either way, we get their sum. The second exercise is pretty easy. It's just to help you get used to the syntax. So I want you to create a circle object using the object literal syntax. Now this object should have a radius property that we can read or write to. For example, we can set circle.radius to 2. It should also have an area property that is read only. So we should not be able to set the area from the outside, but we should be able to read it. For example, we can do a console.log of circle.area. So spend a couple minutes on this exercise. You can see my solution next. All right, so let's declare a circle object. We can give it a radius initially. Now to create a read-only property, we need a getter. So we use the get keyword. Here's the name of our property, but actually it's implemented as a method. Now here we need to return math.py times this.radius times this.radius. Okay? And finally, we can do a console.log of circle.area. Save the changes. So this is what we get if we change radius to a new number and then read the area. We get something different, but we cannot set the area from the outside because this is a read-only property. We don't have a setter here. Now to prove this, even though here I set the area to 20, if I read it again, you can see it has the old value that is computed based on this formula. Earlier in the course, in the section about arrays, we had this exercise to count the number of occurrences of a given element in an array. So this is the solution we wrote for this exercise. If you don't have this, download the source code for all the exercises for this course. You can find this at the beginning of the course in the first section. So in this project, if you look in the arrays folder, the fifth exercise, count occurrences. So I copied that code into index.js to use for this exercise. Now, this function has a tiny problem. Here we're assuming that the first argument is a valid array. What happens if we call this function with a Boolean? We get this error, uncaught type error. Array.reduce is not a function because here we're calling array.reduce and Booleans don't have this reduce method. The same happens if we pass null or undefined or a number. When we pass null, we get a different error. Cannot read property reduce of null. So here we need to modify this function and add error handling. So this is what I want you to do for this exercise. If this first argument is not an array, I want you to throw an exception. Then wrap these two lines with a try-catch block. You can also wrap these entire 3 lines all together in a try-catch block. It doesn't really matter. One of these lines is going to throw an exception. That is the second line, the call to count occurrences function. So there, catch the exception and log it on the console. Again, very simple exercise. It just helps you get used to working with exceptions. You will see my solution next. So in this function, first, we need to validate the first argument. Earlier, you learned about array.isArray method. So we can pass this first argument here. And if this is not a valid array, we want to throw an exception. So throw new error invalid array. You can add any error messages here. It doesn't really matter. Now, you want to wrap this code in a try-catch block. So try, we put these 3 lines there, and then catch. Here we add an identifier for our exception, the error object that we are throwing here. We get that and display its message property on the console. Save the changes. And here's our error message.